Thank you everyone for joining me here today. My name is Geoffrey Huntley. This is myself in the speaker lounge 2 days ago when I got dobbed in my peers saying, you have to write a talk and present today. So bear with me. I'd like to introduce you to something I've been working on for the last couple of years. And that is a project, Reactive UI. Reactive UI is a set of extension methods on the Reactive Extensions. And we cover 9 different platforms, primarily .NET, but we cover all the mobile platforms, even televisions. Samsung Tizen televisions. There's a pull request open right now. We're adding support for the platform, so you can do reactive programming with that. We also have a universal Windows platform, UWP, Windows Forms. A lot of people still using Windows Forms. I have one person who says Reactive UI is the only thing that makes him like programming in Windows Forms. So I still support it for him. Now, Reactive UI inspired the creation of Reactive Coca and Reactive Swift. Reactive Coca was written by a GitHub employee. And Reactive UI, I did not write Reactive UI. It was written by Paul Betts, also a GitHub employee. So over much coffee and beer, they ported the concepts behind Reactive UI across. And it's close to 14,000 stars on GitHub. And it literally changed the way an iOS developer writes applications. So it's not just me. There's a team behind Reactive UI. It was created by Paul. Paul created it whilst at GitHub. And a couple of years ago, he departed the project. He actually crossed over into the JavaScript ecosystem, and he joined to become the lead engineer of Slack and wrote the desktop application that you use on Mac and Windows. And that is using Electron. We also have Kent, who's here in Australia, in Adelaide. Unfortunately, he couldn't be here today. And we have Brendan Foster, someone very, very near to me, special. The project has grown 2 maintainers since the beginning of the year, and we're growing. If you're looking to get started in open source, we'd love to have you on board. We have an ambitious roadmap. So some exciting news last week is Reactive UI joined the .NET Foundation. And this is going to allow us to do some very, very interesting things. I can't wait to share these with you. So this journey myself into open source started 3 years ago. When this guy, Brendan, you'll find him downstairs at the GitHub stand. He wrote a blog post. And he said, I'm setting aside some time each week for mentoring developers. It was the kindest thing I ever said. I couldn't believe someone working at GitHub was going to set aside some time for pair programming. And then what he wrote was, I've been fortunate to have many great mentors in my program career, just to bounce ideas off. Sometimes there's software, sometimes there's not, but someone being there. So he set aside that time. So I dinged him on Skype, and this took unbelievable amount of courage. I was an enterprise developer. I felt like I was at my ceiling. I was stuck. And I knew I had to get out of that job. And I just didn't know what I needed to learn to get out of that, or how to find the joy in software development again. And I dinged him on Skype. It took a huge amount of courage. And finally, someone was challenging me. I was in over my head, and he was there pulling me up. I was learning so fast. The pace was intense. Brendan plugged me into something that changed my direction as a software engineer, and that's reactive programming. And I'd like to do the same for you. A couple of weeks ago, I started doing a lot of live coding and programming on YouTube. And you see over there the light in the background? That's a Philips Hue globe, and when I'm on air, it automatically turns red. So it's kind of cool. So Erin, my wife that is here, she doesn't accidentally run into the room when I'm broadcasting. And I'm teaching everything I know about reactive programming, but not just reactive programming, maintaining a large open source project that's used at GitHub, Slack, Elasticsearch, and a bunch of others. Everything from continuous integration, how to take a .NET, what .NET standard is, how to cross-compile with a new VS 2017 project. I'm there teaching it. I'm setting aside some time like Brendan did, and I hope you take me up on the offer. If you go there, it will redirect to YouTube, and you can follow. So 9 years ago, Bart Desmee and a bunch of other, 4 people, they invented something, the reactive extensions. And what Brendan showed me was this video on duality. And duality is, in mathematics, something of a complete opposite. And Bart, who is here, has done 3 talks. And I highly suggest going back and looking at these talks. They invented the reactive extensions. And what they do on this whiteboard is they pull apart, it's so mentally stimulating, they pull apart reactive programming and show a collection, a list of objects where you would normally pull. You'd normally pull from the collection one by one, and they show how they reverse it. They actually reverse it and turn it from a pull operation to a push operation. There's 2 videos, and it's mind-blowing. And that was the birth of the reactive extensions. At the time, there was a project called Volta. And within Volta, they had some very innovative stuff going on, but they discovered something. And they extracted that something, and it became the reactive extensions. And this was in 2009. So there's many shapes of data. You have single values and multiple values. You also have the notion of time. You have synchronous and asynchronous. For a single value as synchronous, it's just an object, so you new up a class. For multiple values that's synchronous, you have an IObservable, so a list of T. So it's iteratable. You do a get enumerator. Likewise, just coming in recently, in the last couple of years, we now have async and await. So this is when you have a single value that's asynchronous. And this is the most common use of asynchronous programming in .NET now. But there is another one, and then Brendan introduced me to it through that video. And that's IObservable, or observables. So with observables, they're asynchronous and they return multiple times. And this presentation, I'll show you implementations of observable that are in desktop applications and mobile applications, and it would make you really think that this is really useful. Really, really useful. So if you're sick of investing time and energy in learning how frameworks work and you're looking for some direction, instead of investing time in learning Angular 1 and then having to throw that knowledge out, learn something universal. And reactive programming is universal in the sense that on mobile, reactive programming is used extensively in the Android ecosystem. On the back end, it's used in stream processing. On the front end, you now need to know it as part of RxJS. Very, very popular over there. So if you learn reactive programming, what happens is you just apply the concepts that you've learned into a different implementation. So it was created in .NET in 2009, and it is implementations in pretty much every conceivable language known. And RxJS has become incredibly popular the last couple of years. So an example of investing knowledge into reactive programming, investing knowledge into a framework, is developers learned Angular 1, and all of a sudden, Angular 2 came out and had to throw away all their knowledge because they invested time to learn those APIs of reactive programming. Invested time to learn those APIs. And interesting enough, the change that happened was Angular's embraced reactive programming. You now need to know reactive programming to be an Angular developer. So only reactive programming allows you to express the idea in a single place. And this is something that's really, 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 really cool, but it also scares people away at first because it's just so terse. Like it's all combined together. You declare your intent of what you want on a single place, on a single line. Instead of having lots of event handlers in your application, you're scrolling up and down to figure out what you're going to do, it's all declared in a single line. So it's actually easier to debug because you're not scrolling through your application in different locations. But it can look scary at first. Reactive programming can look very, very scary at first. And the best way to look at it is actually Microsoft Excel. Reactive programming is Microsoft Excel. Instead of telling the computer what its job is, instead of telling the computer take A and B and then put it into C, what you're doing is you're saying C should update anytime A or B update. And that's the main thing about reactive programming, is just thinking around how you describe to the computer what the end outcome that you want to occur. So reactive programming has inspired two much-loved JavaScript frameworks. One is Elm, and the other is CycleJS. And these are the equivalents of reactive UI in the web space. So here's an example, like a concrete example of a problem you have when you don't use reactive programming. You have a view model. You have a isBusy property, and that displays a loading indicator when it's enabled. You have a load command, and when that load command is executing, it just turns that indicator on and off. And this is really common. I bet you would find it in your code base today. You just turn on and off, and it's really, really simple until a new requirement comes through, and all of a sudden you've got a race condition in your code. And this is just a simplistic loading and saving, but it can get really, really complicated. This branching of turning this on and off in your code, it's really hard to debug. And handling this complexity is scattered all over the place. But with reactive programming, that's all defined on 2 or 3 lines, just like Microsoft Excel. So here's an example from a code review I did last night. And it's a mobile application written in Xamarin. And it's a loading and saving scenario. And the question is, what happens if both of these are executing? What would happen to the navigation in this mobile application? And there would have to be a crazy fast tapper for this to be a problem. That's a review comment. You have to be a crazy fast tapper. And it's like, okay, we'll let this pass. It's true. You have to be a crazy fast tapper for this to result in a user defect. But if you defined when that isBusy should be on and off like an Excel expression or Excel macro, you wouldn't be in this place in the first place anyway. So I'd like to introduce you to WhenAny. WhenAny is a built-in within Reactive UI. It uses observables, and it's a bunch of extension methods. Now, Paul converted WhenAny over to TypeScript. It is now available. If you afterwards come to me, I'll show you where. But he started porting a lot of the concept behind Reactive UI to TypeScript. That's kind of cool. So WhenAny allows you to say when a dinosaur has scales, or has horns, or has spikes, or has a club. What I'm saying is, when any one of those checkboxes changes, I'm subscribing and listening to the events that occur. It's like the Excel expression, the Excel macro. Then I've got to decide what I do when that happens. So I'll show you the code behind this. This is WhenAny. So it's very, very much like a Excel macro, Excel expression. I'm saying when C changes, so when A or B changes, something should happen with C. So here I'm listening to the weight of the dinosaur. Does it have a club? Does it have a horn? And then I compare it to the dinosaur on the right, and it just determines who wins, like rock, paper, scissors. So it allows you to subscribe to change notifications that are occurring, or sequences. The next primitive that's provided in Reactive UI is ReactiveCommand. When you're building applications, typically you use ICommand. And ICommand is something you bind to a button. But ICommand is missing some things. And what ReactiveCommand does, it provides a bunch of observables that you can subscribe to compose an outcome. First up, we have canExecute. And canExecute's really cool, is we can pass the canExecute into the ICommand, and we can make the ICommand, or the button, automatically disable if that ever becomes true. Likewise, we have isExecuting, exact same scenario there. We can automatically disable or enable the button based on subscribing to these results. And what's extremely cool about this is you can do, it allows you to compose situations like this. Building on the knowledge of WhenAny, you can go, WhenAny, the username and password is not null or string or empty, the login button will activate automatically. And that's using WhenAny. So I do WhenAny, the username and password is not blank, that sends an observable that is subscribed to saying it's true, which means canExecute is true. The button automatically changes to enabled and can be enabled. And it's perfectly efficient. I don't have to go button enable, button disable. It just subscribes to it, just like Excel. It just works. And which means you're doing less screen redraws, so it's more performant. So here's the example. Username, blank. Password, blank. Button automatically updates. So WhenAny, username, password, button enable. And likewise, I take the isExecuting observable from the login button, and that's connected to the canExecute of the cancel button. So right now I can cancel. But the cancel button automatically enables or disables when the login button changes, the state of the login button changes. Super cool. On line 25 is an example of WhenAny. When the username or password is not null, I pass it into the login, and it allows the login to be enabled. So these same concepts, even though this is .NET, this is reactive programming. This is what you can do. Reactive UI is a set of extension methods that allows you to do this, so you can compose an outcome. And luckily, due to Xamarin, this means it runs on all mobile ecosystems. The next one I'd like to show you with an application of reactive programming is from a library called kovash. Kovash is a library used extensively in the .NET ecosystem. It's a key value store, it's a cache. And a lot of people use kovash kind of the wrong way. Well, it's the right way, but they're only using 10% of its capacity. So if you imagine that you have an application for Twitter, for example, you normally have a loading indicator, and you do a network request, and then you display a list of tweets. People normally use kovash and implement it to do show the indicator on, do a network request, which blocks user interaction, and then display the results, because they're using it as a future, a single value. kovash is built on observables. It allows multiple values over time. Why this is cool is it allows you, if the user loads up the Twitter application, it does a request. If the cache result is in the cache, it will return immediately. there's no need for a loading indicator. What you're doing is displaying the tweets straight away to the user. There is no loading indicator needed. And this is one of the properties of multiple values over time, what it allows you to do. And then what you do in the background, while the user is scrolling through their tweets, because and there might have been some background services updating the cache, and they might have 2,000 tweets already there that are unread. You can actually use this to say, go fetch the latest version from my endpoint. And then from there, when that data comes back, you just compose the result. You create a set and you append on the top. The user doesn't even notice what's happened, but a whole bunch of magic's happened and you're no longer blocking user input. And this is some of the properties of what observables allow you to do. I get really annoyed when I see loading indicators. It's not needed. You don't need to do it. Display the old data the user was using, and then silently in the background, retrieve and refresh. The loading operations should be passive to the user. The next thing I'd like to show you is observable from event pattern. So who uses event handlers? Same thing applies for if you're JavaScript, you're working with the DOM, you're subscribing to the DOM and the DOM events. So observable from event pattern converts event handlers or events into observables. Really, really cool. Because you can compose outcomes with this. So within Reactive UI, we have a project called Event Builder. And what Event Builder does is it generates all of the observable properties for that particular platform. And you can use it to compose an outcome. So I'd like to show you an example of subscribing to events in a WPF application that does a cheat code that's very popular in computer games. All right, so I'm going to go up, up, down, down, left, right, A, B. We've got the sequence. It works. It's great. And the actual implementation of this is, like promised, it's all defined in a single place. It's not scattered up and down. You're not listening to a bunch of event handlers. You can now map the world. They can be keyboard sequences, they can be mouse clicks, they can be data coming down from a REST API, it could be GPS coordinates or locations. They're all compatible. They're all events that can be converted into observables. When you have an observable, you can use WhenAny to derive an outcome. Cool. So what we do here is on the main window for WPF, I have an events extension. And anytime there's a key up event, I'm selecting the key, and then I put it into a window of the last 10 keys. And then I compare it to the sequence for the cheat code. And if it matches, it's the sequence. If it's not, it's not. So this was contributed by Brad many years ago. It was one of his first contributions to the Reactive UI project. And I learned this only a couple of days ago. I didn't know it was him. I thought Paul wrote it, but thank you, Brad. And in that, the inspiration behind this came from F#. It's just cool. So another thing that's cool with reactive programming is schedulers, is time. A lot of people don't handle time correctly in their mobile application or even desktop applications. Time is a gigantic bag of mutable sadness, right? It's really hard to test. Most people in .NET do datetime.now, right? And as soon as you just do datetime.now or thread.sleep 10 seconds, you're tightly coupled to the computer's clock. And it makes testing really, really hard. So in Reactive Extensions, there's this thing called schedulers, and schedulers is like a virtual clock. So now imagine that you're sitting down for an interview, and this is the programming challenge that they've given you. I got this a couple years back. It was interesting. The lights will change every 5 minutes. Simple enough, they're traffic lights. Provide the output for the light changes that happen between 9 AM and 9:30. Okay, that's simple enough. You must provide all unit tests for this programming challenge. And what they're specifically looking for here is how fast do unit tests run? How fast do unit tests run for the traffic intersection? If I tightly coupled to datetime.now and did it in an imperative form, these unit tests could take a very long time to run. They would take 30 minutes to run. But the implementation using reactive programming was simple. The tests execute in less than 10 milliseconds because time is virtual. So here's an implementation. You start with a traffic light controller and you pass in a scheduler. Up the top is a bunch of extension methods provided to generate you a mocked scheduler in Reactive Extensions. And you assert the default state should be red for safety. That's like the right thing to do, because if something went wrong and it was like red-green, that's really bad, or green-green, that's really bad. And then you take the scheduler and you can tell it to advance time. You can not only forward time, you can actually rewind time with Reactive Extensions. You become like a complete time lord. There's a talk at Ignite by Joe Alibari of LinkPad, who talks about becoming a time lord with this thing. It's on the Reactive UI website. It's worth a look. So at first, we advanced by 1 second, and we've gone from red to red-green in the state machine, and then we advance it by 270 seconds. So instead of this test taking 270 seconds, it's now just taking 10 milliseconds. Awesome. So here's another example. All right, so we have a dinosaur. We have a loading indicator. And whilst this command is executing, it's like a progress indicator. And typically, if you're doing any form of testing for a loading indicator, you really can't. You've got to wait real time, especially with UI testing. You can mock in a virtual scheduler and improve the performance of this. And it's just easy to work with because time is testable. So a common function that people do in their application is undo. You see this in Gmail. When you compose an email, it's like, are you sure you want to send that email? And it gives you an undo. It gives you an undo operation. So this is how you do undo with reactive programming. So we have a list of dinosaurs here. The delete command is automatically enabled because I've selected something. And that's based off ReactiveCommand and can execute and with WhenAny. And now if I delete a dinosaur, what happens is it pops up something that's inbuilt into Reactive UI called an interaction. And these interactions are completely testable. Because you can fast forward time, you can pop an interaction and then fast forward the clock and assert that this was displayed for 5 seconds, then dismissed, as a unit test, not as an integration end-to-end test, which is like cool. So if I delete this, if I delete the top dinosaur, I got 4 seconds to click undo, go straight to the top. Cool, really easy to implement, and it's all based off the concepts from before. Now, resilience is something interesting. There's this really good library, the .NET ecosystem called Fody. A very good library, the .NET ecosystem called Poly. And poly allows you to construct what you should do if there's a failure. But it is a third-party library. It's not something that's built into the design of the construct that you're programming in. So it doesn't really fit quite naturally. With a reactive extension, there's a whole bunch of operators, and one of the operators is retry. You can retry an operation by just using the word .retry. Really, really cool. So, baked in by default. So, Paul Betts recently said, Vim, reactive extensions, and WhenDebug is probably the three things that keep paying off in his job for the last 10 years. And they have a reputation for being hard to learn, and that is true, but software engineering is hard. It is learnable. And the thing about reactive programming, it's the knowledge is universal. You learn it here. I can now cross over and become an Angular developer quite easily in comparison. I just got to learn to express myself as a JavaScript developer instead of a .NET developer. And you typically can't say that about much technologies. So it's just cool. But I kind of debate with him that it's like hard to learn. It is, but I don't think it's been taught right. So this example shown here today is coming out of a book written by Kent. Kent is one of the other maintainers. As of last night, he's opened up for pre-orders for the book, and it shows you how to build a reactive application using reactive UI or just observables. And the demos I've been showing you is coming from his book. That's exactly what it is. And the community's been asking for something like this for a very long time. So that's available now at reactiveui.net/book. In addition, if you ever used GitHub for Windows or in Visual Studio, you've seen this extension for using using GitHub in Visual Studio. That extension is actually written in Reactive UI. And the full source code of that Visual Studio plugin, which is in the Visual Studio installer, is there. So you ever wanted like a reference implementation of how do you unit test, how observables, how do I do OTAP authentication, or like 2FA in a reactive manner. Every feature you see there is right there in that source code. Very, very easy, and that helps a lot of people with the transition of seeing a fully fledged enterprise application that's supported in production. Source code's there. In addition, we started collecting a lot of these videos. This video and this presentation today will be there eventually. Likewise, we've been starting to run virtual meetups. So we're getting people all around the world and we're learning reactive programming together. One of the best ways to learn reactive programming is just having someone there to teach you. It's just having someone to ask that question to, what if? Because you have to start thinking in a different manner. So I have people who have joined in from Brazil, a place in France, Rio, Dominican Congo. It's amazing. Virtual meetups are going to start become more and more of a thing for advanced technologies, because there still isn't enough critical mass in thinking to hold a local meetup. But there are people all around the world who want to learn these techniques, so we run these meetups online. And the format's working. The Orleans project is also doing this as well. Really cool. And kind of into the future of education to make reactive programming easier is, I think we need to get reactive UI into the web browser. Not to write applications, but just for education. I want someone to be able to use reactive UI without having to download a solution, without having to compile something, without having to load up LinkPad. Just click a link and you're running .NET in your web browser. So Miguel last week said, I love WebAssembly. So I nagged him a little bit and said, Xamarin Workbooks needs to run in the web browser. And he goes, that guy has the man with a plan. So it's not an official product announcement, but they're thinking about it. Then a couple of days ago, this happened. .NET is now running in the web browser. There was a presentation here 2 days ago on Blazor. Now Blazor is not mono. It's a small implementation. You can't run everything that you expect in .NET. Mono is now running in your browser, which is like the next logical step. So I run a newsletter, weeklyxamarin.com. If you want to keep up to date with like how this is progressing, these advancements, sign up there. It's just like a newsletter to you from me. Okay, because the classic way of teaching reactive programming is using marble diagrams, and all the innovative ways of teaching reactive programming is all in JavaScript. Now the problem with JavaScript, if you're a .NET developer, is, well, that's cool. You're telling me what that is, but I can't really see the implementation. I can't really understand that. And if this continues to advance in this direction, we will soon be able to hold training and educational resources to teach reactive programming, but on the left-hand side, instead of RxJS, and interesting enough, that is observable from Event Handler. That's the JavaScript implementation in RxJS. We'll soon be able to teach reactive programming in .NET in the web browser without the user having to download anything, and that's going to unlock a lot of things as far as developer experience and making it more accessible. So here we have a text box. When any value in that text box changes, I'm going to draw a marble. And that marble represents the key stroke that I press. And that's not working. So a marble diagram represents a sequence of changes over time. So what was meant to happen here in the animation is when I press a key, when I press a letter, that letter is shown and it just goes back. If I press the next character, the marble is shown, it just goes back. And it's a way of modeling the world. It's a very, very powerful teaching implement. So there's a huge community behind reactive program. We all kind of hang out together. Like the RxJS community and the Reactive UI community, we're in the same Slack instance. We sit there in one channel, they sit there in the other channel. And if you're looking to get started in open source, you want to learn reactive programming, I invite you to come join us. Come join us. There's so many ways to help out in open source. And if you help out, we'll pay it forward on the off chance that you also will pay it forward to the next person, because the best way to learn it is together. And some of the best ways to contribute open source are non-code related. There was a recent survey by GitHub that says documentation is highly valued but often overlooked. Often overlooked. And last month I've been working on building out the Reactive UI documentation. And in particular, there's a contributing guide now. There's even a guide for grammar, voice, and tone, because Reactive UI is starting to generate revenue, and we're looking at maybe we can hire someone as a tech writer overseas with a limited budget that we have. But first, they need to have some guides for contributing. So I've been mashing out this documentation, but not really following those guidelines. And people are sending in pull requests and being my editors. It's great. I can't even explain it. It's like the best feeling in the world. You want to make a maintainer happy? Fix a spelling mistake. It's easy to review, easy to approve. You made a contribution. It's better. You've helped me. We love it. Help write documentation, spelling mistakes, grammar, you name it. Even if it's tiny, it's everything. It's the best thing to fix. So thank you for joining me here today. Mentioned before, I'm broadcasting on YouTube, sharing my knowledge. Unlike Brendan, who was able to offer direct one-on-one, some of the things I've got planned in the roadmap, it needs to be scalable. Otherwise, as a maintainer, I'll burn out. So anytime you ask me a question, I'm going to create a video or broadcast live, like the answer for it, because other people are also going to ask those questions. So I'll direct them to that resource. So with that in play, thank you very much.